So let us look at carbohydrates. We want to understand what carbohydrates are, what are they made up of, and of what uses are these carbohydrates. Okay, so we start with a scenario. We are talking about a marathon runner. This is Maria. Maria eats a banana an hour before the race to give her energy. She notices she feels stronger at the start, but she tires halfway through the marathon. So, can you tell us the role of the carbohydrates in relation to this marathon runner, Maria? And then, two, can you suggest why Maria might have gotten tired halfway through the race, even after eating a banana, which we suppose contains carbohydrates? And then, name one complex carbohydrate Maria could eat instead, and explain why it might help her sustain energy longer compared to the banana, because we have seen that she has eaten a banana and it has not really helped her that much. So what else could you recommend for her as a person who is well aware of nutritional values in the different foods? So carbohydrates are actually macromolecules. So they fall into the same category like proteins and lipids. We also have other macro biomolecules like the nucleic acids that form the DNA and RNA. But of course, for the foods that we are talking about, we're talking about carbohydrates being one of the major nutrients that our bodies actually need. So carbohydrates do contain carbon, hydrogen, and oxygen. Okay, those are the things that form carbohydrates. So what you basically see on your screen is glucose. What you see on your screen is glucose. This is basically glucose. Okay, that is glucose. So the general formula for carbohydrates is that you have C and then that X and then the Y. That means that if you have that X as let us say 6, the implication will be that if you have X as 6 and then also you have Y as 6, that is that actually means that you get that, because you say C6 and then since this Y is also 6, you get 12. And then if the Y is also 6, because this 12 is coming in because we are multiplying this 6 times 2. And then this oxygen will actually be 12. Okay, and still you get that glucose. So if you want to talk about a sugar that has 5 carbon atoms, it's still the same. You can put you can say that X is 5, and then also you have that Y that can stand also for the other group of atoms. Okay, so that is the general formula. So carbohydrates, what are the properties of carbohydrates? Carbohydrates, we have a variety of carbohydrates, very simple and complex or compound. The meaning of this is that, yes, these carbohydrates, we have those that have several molecules combining. Some of these molecules that are combining are not the same. In some cases, it's the same repeated units combining. So you can have small, simple molecules. For example, glucose, that is simple. And then you have very complex, like glycogen, starch, let us say cellulose. These are complex compounds, but they are still carbohydrates. Okay. carbohydrates give us energy. If we eat foods that contain carbohydrates, we get energy. And in the case of the marathon runner, Maria, banana is an example that gives you simple sugars actually, and then you get that energy, instant energy, because you don't need a lot of metabolic activity to give you energy from the simple sugars that is contained in the ones that we have in the banana. Okay, so we can test for sugars, what we term as reducing sugars, and we shall know how that happens using Benedict's solution, or we can carry out Benedict's test to confirm presence of reducing sugars. So some of these sugars are actually reducing in nature, and we shall look at what sugars are basically reducing. So like I said, that these carbohydrates give us energy, but that's not the only thing. You can have some of these carbohydrates combining with different molecules to do different functions. So we can look at those. The body mainly uses carbohydrates for source of energy. Whether you want instant energy or you want energy that is sustained. Okay, so when you have sugars being released into the bloodstream for metabolism to be broken down to give you that energy, you may need complex sugars such that you have that sustained release of these sugars. Or if you want instant energy, you just get, for example, glucose. Take it, you get that sugar that you want instantly. Same if you get sugar, sucrose, the table sugar that you can take, you still get that what? That burst of energy very fast. Okay, so of course the carbohydrates can actually be stored, and then they can be broken down to release sugars at a rate that we want. Okay, so in humans, for example, you have glycogen being the storage form of these carbohydrates, and they can only be released, broken down to release glucose when the body actually needs that. Okay, so that means that carbohydrates play an important role in regulation in that glucose levels. Like I said, that carbohydrates actually do combine with the other components, for example, proteins, for us to get glycoproteins. So where do we get these glycoproteins? Glycoproteins can be found in cell membranes, and they play very important roles in the cell membrane, including signaling. Okay, these sugars are actually very important for the brain to function very well. If the brain is deprived of sugars, then you will have problems. Okay, you will have problems. You can collapse. You will feel dizzy and collapse, faint, basically. So that means that you constantly need glucose, especially in your blood, such that the brain can keep working. And if the brain does not work for a minute, it's very, very, very big problem that you're having in there. Okay, so the performance of your brain, that is cognitive function or cognitive performance, is reduced if you don't have sufficient sugars. Okay, so we can use these sugars or carbohydrates to make other things. I already talked about the glycoproteins, but there are also other molecules that are very important, but that can actually be made from carbohydrates. Okay, we have talked about the glycoprotein cell membranes, and also being part of carbohydrates can be used for making extracellular structures. Okay, and then the point about energy, we have already explained that. So carbohydrates are diverse. There are many carbohydrates, those that are simple, those that are complex. Those that are complex include cellulose, glycogen, and starch. Those are complex sugars, or basically complex carbohydrates. And then simple sugars are those that you don't need to hydrolyze further to basically break them down to produce energy. So they are not very large molecules. So glycogen, the carbohydrate storage form in animals, and then for starch is the storage form of carbohydrates in plants. And then cellulose is basically what we find in plants also. So the structure of cellulose and starch. We need to look at that later on and see, okay, these are all carbohydrates in plants, but what's the difference? Okay, like I said earlier on, starch storage form in plants, it's a polysaccharide. The meaning of that is that the carbohydrates, the complex ones especially, are made as a result of combination of small units that we call monomers to give you a very large unit that we call a polymer. So a polysaccharide is that large carbohydrate that is formed as a result of having many monomers combining through polymerization. So we are saying that starch is a polysaccharide, very complex with many monomers, and it is found in plants. It forms as the storage, energy storage molecule in plants, and later on we shall see why is starch a very good carbohydrate storage molecule in plants. And then glycogen, again, polysaccharide, found in animals instead, and still energy storage in animals. Okay, particularly this glycogen is in the liver and also the muscles. So later on, you should be able to answer why starch and glycogen form very good storage molecules. Okay, like we said earlier on, we can categorize carbohydrates into either complex carbohydrates or compound carbohydrates and simple carbohydrates. But basically, for us to rhyme with what all other scientists are actually saying, we can say that carbohydrates are categorized into monosaccharides, disaccharides, and polysaccharides. Okay, that's what we can always use. Okay, so the monosaccharides, these are simple sugars. Okay, disaccharides, you can also say that they are actually simple sugars, and then polysaccharides, those are complex sugars, or basically compound sugars. That means that you really need to break them down for you to get disaccharides and monosaccharides. So what we basically have here is that if someone eats a banana, the banana actually contains glucose, which are basically simple sugars. And because you have simple sugars in this banana, you will get energy instantly because it is this glucose that is directly burnt, if I can use that, is directly broken down in the process of respiration to give you energy. So you don't need to convert this glucose into smaller sugars again for you to have energy. So that means that when you eat it, you get that energy that you want, but it will not be sustained. The meaning of that is that you will not run a longer race depending on that energy that you have gotten from the banana. It will not, because this is a simple sugar that is broken down to release energy instantly, almost instantly. But if you eat, for example, cassava, that the cassava is actually having the starch. So with the starch, the process of absorption of the final simple sugars from this starch is going to be a longer process. Why? Because when you take in this cassava, your digestive system has to handle this cassava and break it down into simple sugars that can be absorbed into the bloodstream. And that is not going to happen at an instant because the process of breaking or digesting this cassava will take time. And consequently, you have steady release of these sugars into your bloodstream. And that means that you have steady supply of these simple sugars that can continuously be broken down through the process of respiration to give you that energy that you actually need for the marathon. And that's why in this case, the banana is not the suitable alternative, but for example, cassava can be. So what we basically talk about here is that you need a carbohydrate that is a polysaccharide that will give you that steady release of simple sugars that you basically require for this sustained activity. So that is what we have in this scenario.